Welcome to today's talk about using optical coherence tomography for advanced lens metrology. My name is Ben COldrick and I am a Director of Optimec Systems Limited. I have the honour to present to you today our OCT technology and how it can be used for advanced lens measurement across contact and intraocular lens production. Optimec Systems was formed in 2020, following the closure of Optimec Limited, who you may be familiar with. We are based in Malvern in the United Kingdom and have a dedicated team with many years' experience in the contact lens industry and in industrial automation. We are ISO 9001 certified and members of a number of industry bodies. Optimec Systems provide measurement systems for the contact and intraocular lens industry, covering the complete production cycle from in-process measurement to final measurement. We also offer service, support and expertise to ensure that our customers get the maximum benefit from our technology. Our measurement technology is based on optical coherence tomography, which you may already be familiar with from the ophthalmic sector. I would like to provide a brief overview of this technology before I can demonstrate its benefits and usage within our products. You most likely have seen OCT for imaging the eye. Commonly it is used for inspection of the retina or the anterior segment of the eye. In both cases, the complex geometries and layering of the eye can be seen thanks to how the technology works. This is important for its use in contact lens measurement, such as we do at Optimec Systems. The simplest way to think about OCT is that it is like ultrasonic measurement. A light pulse is sent into a sample, and the reflections, like sound echoes in ultrasonic, are received and analysed. There are broadly three types of OCT technology. The first, time domain, uses a time difference between the reflections to build up an image of the layers of a sample. The other two, spectral domain and swept source, use the interference between frequencies to build up the image. The method we use at Optimec Systems is spectral domain OCT. In principle, a broadband light source is split into two paths, one to a reference mirror and one to a sample. The return light from both, including any layers to the sample, is combined and recorded as a function of intensity by a spectrometer. By using a Fourier transform, this information can be translated into the location positions of layers within a sample. This transform and subsequent translation into position data is conducted at a single position, called an A-scan. Multiple A-scans can be captured across a sample in any direction using a movable mirror, with the combination of A-scans forming a B-scan or OCT image. The IS-830 metrology system is then able to take this image and extract the front and back surfaces of a sample, allowing a wide range of geometric parameters to be measured. So how do we take these OCT images and convert them into useful metrology data? The key understanding needed to analyse OCT imagery is that light refracts as it passes through materials scanned by the OCT system. This can be seen in these images here, where A is the original OCT image of a water drop on a flat microscope slide, and B shows what this should look like in reality. Overlaying the refraction at different points highlights the difference. As a result of the refraction, all OCT images are distorted, and this distortion needs to be removed to obtain accurate data. Optimec Systems developed a number of algorithms to do this, allowing sample surfaces to be extracted and dewarped based on the refractive index of the samples and the measurement medium. This allowed complex geometries to be quickly and accurately measured, as shown on the right here. C shows the original image of a lens in saline, and D shows both the dewarped real lens outline, the solid lines, in comparison to the dotted original outline. OCT technology has a number of unique benefits for the measurement of contact and intraocular lenses. The first is that all data is captured without physically contacting the samples. Data can also be obtained for samples in air or immersed in fluid. Data can be captured from both surfaces in a single scan and at any position on a lens. Access is also not required from both sides to obtain the image data. And finally, measurement is fast, with a typical single scan from the IS830 system measured in less than a single second. OCT is implemented in the Optimec IS830, our flagship product. This short video demonstrates the system, which is a benchtop metrology system. So the system is able to measure samples both in the wet and the dry, and allows a wide range of samples to be measured. To demonstrate the capability of the IS830, these are some of the common measurements obtained by our customers, including thickness at any position, curvature of all surfaces, sagittal depth at any position, and diameter measurement. The IS830 can also extract more complex measurements, which are becoming increasingly common with the growth of ortho-K and scleral lens designs. These include peripheral curvature inspection, such as the measurement of reverse curvature geometry, landing zone angles relevant for scleral lenses, and detailed sagittal depth comparisons between different chords for detailed lens profiling. As OCT allows multiple meridians of a lens to be measured, the IS830 can also build a 3D map of sample data. For each meridian, data such as thickness, as shown here, or sagittal depth is captured. With additional meridians captured, these can be combined to allow the full lens to be visualized and measured, as shown here for thickness and sagittal depth. For IOLs, the same type of measurements are possible, including thickness, curvature, and diameter measurement. OCT also allows for more complex studies to be undertaken, such as changes over time. Here is an example of a contact lens hydrating, captured over a period of 20 minutes, where you can see the hydration process in detail, with the saline penetrating into the lens material and changing the shape as it transitions from dry to hydrated. Here is another example where we can see two videos showing how an IOL passes through an IOL injector, visualizing both the rolled IOL and how it is pushed out of the injector into fluid. A big advantage of OCT is the ability to measure samples in process, which is where the IS830 Auto product can be used. The Optimec IS830 Auto uses the same measurement technology as the standard benchtop IS830, packaged into a new enclosure that allows for a versatile automation offering. To demonstrate the potential for OCT measurement in production, here is an overview of a typical lathe-based manufacturing process. As can be seen, there are a number of measurement points that may be used with current technologies, but full measurement is not possible until the lens is deblocked or removed from production tooling. In addition, multiple technologies are required to obtain these measurements. With the IS830, all of these measurement points and additional ones are possible. The IS830 can also provide full measurement whilst the sample is still on production tooling. For moulded manufacture, as with lens manufacture, there are a number of measurement stages currently used. However, again, the IS830 can cover all of these and more, and allows for full measurement earlier in the process. For IOL manufacture, it is a similar story, including measurement across both the lathing and milling process. Again, the IS830 can be used to measure across the process at multiple stages, covering both lathing and milling. Here we can see some examples of the imaging capability of OCT in process, with both of these examples captured of samples still mounted to the production elements. With OCT, the full geometric surface can be extracted, and after the second cut in this example, the full lens can be inspected while still mounted to the tool. This provides a clear benefit to manufacturers, as product is able to be checked before lengthy operations take place, such as hydration for soft lenses or milling and tumble polishing for IOLs, ensuring time is not wasted and unnecessary costs incurred on defective products, or even allowing an opportunity for adjustment to reduce wastage. With advanced metrology in the manufacturing cycle, comparisons to actual lens design data can be made, including comparisons of exact shape geometry for custom lenses, something not easily achievable until now, which we can see here in this example, where the same design was measured at different stages, all measured on a single system. So here is an overlay of the lens still mounted to production tooling on top of the first production stage. And here the final lens after measurements overlaid on the previous two stages, all measured on a single system, allowing complete measurement across the production cycle. With the combination of advanced metrology methods and automation expertise, Optimec systems are able to offer customization of the IS830 Auto, both in terms of how it is integrated and the measurement output of the system, allowing bespoke implementation of the technology for customers' production. There are many methods of integration possible, including a tray-based system, positioning the IS830 Auto above a conveyor system, or even using industrial collaborative robots to position lenses under the measurement head. This video demonstrates a bespoke tray-based solution implemented at an IOL manufacturer for the measurement of IOL blanks. The implementation of this system resulted in improvements in throughput and a reduction in wastage for the manufacturer. So as can be seen, there is a lot of potential for using OCT in contact lens and IOL production. At Optimec Systems, we feel the best way to see the potential is to have a demonstration. We offer a range of methods for doing that, including measurements of your samples through a lens report or a remote live demonstration. We can also offer system evaluations on your site. We have a wide range of experience in what OCT can offer to the contact lens and IOL industry, so please just ask us. That brings me to the end of my presentation. I hope that this has been interesting for you to see how OCT that you may use day to day can be applied in other areas. I would like to thank you for your attention and will look forward to any inquiries about what Optimec Systems can do for you.